Hello. Today I'm going to teach you how to factor a quadratic function and find the roots. The roots of a function are where the function passes over the x-intercept or where x is equal to 0. The first way we can find the roots of a function is using the quadratic formula. This here, what I've just boxed in, is the quadratic formula. And you can plug in any quadratic into it and it will return the values where y is equal to 0. You might be wondering, what is b, a, and c? Well, this is what they are. The coefficient attached to x squared is your a value. The coefficient attached to the x is your b value. And the constant at the end is your c value. So let's do an example and see how we would find the roots of this polynomial function. You can say x is equal to negative b, and b is 6. So negative 6 plus or minus the square root of b squared. So b squared is 6 squared, so that was just 36, minus 4ac. So minus 4 times a is 3 times c is 2, all over 2a, 2 times 3. Now let's simplify. X is equal to negative 6 plus or minus, and now we can see here that inside of the square root sign is 36 minus 4 times 3 times 2. 4 times 3 is 12, times 2 is 24, and 36 minus 24 is 12. So we can say plus or minus root 12 all over 2 times 3 is 6. And now this leaves us with two answers. Our first answer is x is equal to negative 6 plus root 12 all over 6. And our second answer is negative 6 minus root 12 all over 6. Okay, the first way we can factor a function is by finding two numbers that add to b and multiply to c. So we can see on our first example that our a is 1, our b is negative 5, and our c is negative 6. So we need to find two numbers that multiply to negative 6 and add to negative 5, just like that. After some thought, you'll realize that these numbers are negative 6 and 1. That's because negative 6 times 1 is just negative 6, and negative 6 plus 1 is negative 5. So in order to factor this function, all you have to do is draw two brackets, just like so. Put x here in the beginning of the first one, in the beginning of both, and then write those two numbers that you've thought of. So the first one is negative 6, and then the second one is 1. So then we write plus 1. And that is our factored form of this function. You can always double check, and it's always a good idea to, by foiling. If you're not sure how to foil, we have another video on how to foil that will be coming out soon. And we can foil this here by doing x times x is x squared. X times 1 is just x. Negative 6 times x is negative 6x. And negative 6 times 1 is negative 6. After we simplify, we'll be left with x squared minus 5x minus 6, which is just like the original. All right, let's see the next one. Okay, our second quadratic is x squared plus 12x plus 27. So just like the first time, we need to find two numbers that multiply to c, which is 27, so multiplies to 27, and adds to b, which is 12. After some thought and trial and error, you'll realize that these two numbers are 3 and 9. That's because 3 times 9 is 27, and 3 plus 9 is 12. So just like last time, draw your two brackets, put x at the beginning of both, and then write the two numbers that you came up with. So plus 3 and plus 9. Now I'm not going to do it again, but if you were to FOIL these two brackets, you would get the same as the original. What this means now is that the roots of this function are x equals negative 3 and x equals negative 9. That's because if you were to substitute negative 3 or negative 9 into this function here, you'd be given 0. Okay, let's try one more example. What is the factored form of x squared minus 5x plus 4? So just like the last two examples, we need to find two numbers that multiply to 4 and add to negative 5. These two numbers are negative 4 and negative 1. That's because negative 4 plus negative 1 is negative 5, and negative 4 times negative 1 is 4. So, just like the last two examples, put our brackets here, write our x in the beginning of both of them, and then write the two numbers that we thought of, which is negative 4 and negative 1. This would give us x minus 4 and x minus 1. This means that the roots of this function are at x equals 4 and at x equals 1, because if you were to substitute them in, the function would equal 0. Our next method of factoring is by doing difference of squares. Difference of squares is a good method when you don't have a b term. So when you don't have an x term, it's just x squared and a constant. What you do when you want to factor by difference of squares is you write two brackets like this. You do one with a minus sign and then one with a plus sign, just like that. And then you write the square root of the first value and the square root of the second value for each bracket. So this here, the square root of x squared is just x, and the square root of 9 is 3. And then the same for this bracket. So this leaves us with x minus 3 and x plus 3. That means that the root of this function, the roots of this function is x equals 3 and x equals negative 3. We can FOIL to see if this is the right answer. X times x is x squared. X times 3 is 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. Simplifying will give us x squared minus 9 as our final answer. So we know this is right. Now let's try this one. At first, you might not be able to realize that we can do difference of squares because 5 does not have a integer square root. But we still can, it doesn't matter. So just like last time, write your two brackets, put an addition in the first one and a subtraction in the second, or the other way around, it doesn't really matter. And then take the square root of the first value here and the square root of the second value here. So the square root of x squared is x, and the square root of 5 is the root of 5. Just like this. We don't need to simplify. And this is our factored form of this function. Now our last example here looks a little different. We see here that we have a integer value for a that isn't 1, and we see that this is raised to the power of 4. This is still a difference of squares. Nothing changes here. We can write our two brackets, put an addition sign in the first one and a subtraction sign in the second, or the other way around, and then we take the square root of the first term here, and that would be 4x squared. And we know this because 4x squared times 4x squared is 16x cubed. And we take the square root of the second value, which is 25. And the same for the second bracket. Okay. This is not fully factored. The reason for this is that we have another difference of squares right here. I should also make a note that you cannot do a difference of cubes. Here, you cannot factor any further. This is the last step for this first bracket. The second bracket can be factored further. Let's see how we would do it. So I'm going to write the first bracket down and leave it alone. And now let's factor the second bracket. We can do difference of squares on this bracket as well. So we write out our two brackets. And just like last time, put our plus and minus sign in each of the brackets. And now we can take the square root of 4x squared. This is 2x. And then we can take the square root of 25. That's 5. And now this is our fully factored function. If we were to FOIL all three of these brackets, we would be able to simplify to 16x to the 4 minus 125. I'm not going to do that because that would take way too long, but if you'd like to try it, go right ahead. The last method I'd like to teach you is factor by grouping. The premise of factor by grouping is taking this middle term here, our b, so in this case it's our 11x, and writing it as two separate x terms that we can break up. The best way to explain it would be through an example. So let's start with this. 5x squared. And with this example, we can see that 11 can be broken down into 5 plus 6. So we can write plus 5x plus 6x plus 6. And you can see that if we wanted to simplify this, it could simplify to the original because 5x plus 6x is 11x. So this is okay because we haven't actually changed the function at all. We've just written it a different way. It would be equivalent to writing, let's say, plus 1 minus 1 on the end of a function. It doesn't change anything about it. Okay, so now what we can do is I like to think of putting like a wall here and thinking about each of these separately. The main goal is to factor out a number so that we'll be left with something inside of the brackets that is the same for both sides. So for this here, we can factor out a 5x. And this will be leaving us with x plus 1 inside of this bracket here. Now, what can we factor out of the second side of this equation? To leave us with an x plus 1 on the inside of the bracket. That's just 6. So we write 6, and then after we factor the 6 out, we'll be left with x plus 1, just like that. Now, the last step is to just write whatever is outside the brackets inside a bracket. So this becomes 5x plus 6. And our second bracket is just whatever this bracket is. So this is just x plus 1. And this would be our fully factored form using factoring by grouping. Okay, our second example here is the function 3x squared minus 2x minus 5. So just like last time, our goal will be to break up this negative 2x into two terms that would sum to negative 2x. So by looking at this, we can see that we could break this up into, so we can write the 3x squared, and then we can break this up into plus 3x minus 5x minus 5. This is because 3x minus 5x leaves us with negative 2x, so we haven't changed this function at all. Now, the same as the last example, let's factor something out of each side of this equation that will leave us with the same thing inside of the brackets for each side. So for the first one, let's factor out 3x. Well, that will leave us with x plus 1 inside of the brackets. Same with the other side. Let's factor out a negative 5. Now what will be inside of the brackets will just be x plus 1. Then what we can do, just like last time, is write everything that's outside of the brackets inside of one bracket. So this would become 3x minus 5. And then we just write whatever's inside of these brackets as one bracket. So this becomes x plus 1. And this here would be the fully factored form of this function. Okay, here's our final example. The function 3x squared plus 6x minus 9. Now before we do anything, we have to notice that we can factor out a 3 from this function. This will make it much easier for us to solve. So let's do that. Let's factor out a 3, which will leave us with x squared plus 2x minus 3, just like that. And now, since we have a value of 1, because the coefficient attached to this x squared is just 1, we can look for a number that multiplies to negative 3 and adds to 2. After some thought and trial and error, you can figure out that these values are 3 and negative 1. That's because 3 times negative 1 is negative 3, and 3 plus negative 1 is 2. So we can do the same thing as last time. Put our two brackets, and x is in the front, and write the two numbers that we've thought of, and that's 3 and negative 1. So x plus 3, x plus 3, and x minus 1. This means that the roots of this function are at x equals negative 3 and x equals 1. That's because if you were to sub in either of these x values into this equation, we'd be left with a value of 0, which is what a root is. I hope this video helped you learn how to factor. If it did, please consider leaving a thumbs up and subscribing. Thank you. Have a great day.